यहाँ पर आपको एजुकेशन, एक्सप्लेनेशन, टॉप 10 क्वेश्चंस, इंपॉर्टेंट क्वेश्चंस और एग्जाम्स के मुताबिक न्यू अपडेट्स मिलती रहेंगी।
My dear students, welcome back to our channel. In this video, I will be explaining the MBA third semester subject DBMS Database Management System as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 2 first important short question is SQL 3. SQL 3, also called SQL 1999, is the advanced version of SQL, structured query language. Used in modern database management systems, DBMS. It extends the basic SQL, SQL1 and SQL2 to support complex data types, object-oriented features, and better data management. With SQL 3, you can store and manage complex data like images, videos, audio, and structured objects, not just numbers or text. It also allows user-defined types, inheritance, and advanced constraints, making databases more powerful and flexible. Example: in a university database, a student object can include basic info, name, role no, and methods like calculate grade or update address. SQL 3 lets the database store these objects and perform operations on them directly. SQL 3 is widely used in object-relational databases and helps combine object-oriented programming with traditional relational databases. Easy to remember. SQL 3 is equal to SQL plus objects plus complex data. It allows DBMS to handle real-world applications like multimedia, banking, and engineering databases efficiently. Next important short question is 2. MySQL. MySQL is a popular open-source relational database management system, RDBMS, used to store, manage, and retrieve data efficiently. It follows the relational model, which organizes data in tables with rows and columns. MySQL is fast, reliable, and widely used for web applications, websites, and business software. Example: in an online shopping website, MySQL stores information about products, customers, orders, and payments. Tables like customers, orders, and products are connected using primary and foreign keys, making it easy to access and manage data. Key features: supports SQL commands for data operations, select, insert, update, delete. Handles large volumes of data. Ensures data security and integrity. Multi-user access with concurrent connections. Easy to remember. MySQL is equal to tables plus SQL plus fast and free database. Because it is open source and easy to use, MySQL is widely preferred by students, startups, and companies for building reliable applications. Next important short question is 3. DB2. DB2 is a relational database management system, RDBMS, developed by IBM. It is used to store, organize, and manage data in a structured way and is known for high performance, reliability, and scalability. DB2 can handle large databases and is used in banks, insurance companies, and large enterprises. DB2 supports SQL for querying data and also includes advanced features like data security, backup, recovery, and support for multiple platforms, Windows, Linux, Unix, and mainframes. Example: in a bank, DB2 manages customer information, account details, transactions, and loan records. When a customer checks their account balance online, DB2 retrieves the data quickly and accurately. Key advantages: reliable and secure. Handles large enterprise data. Multi-platform support. Advanced performance features. Easy to remember. DB2 is equal to IBM database plus secure plus fast plus enterprise ready. DB2 is ideal for organizations that need robust and scalable database solutions. Next important short question is: 4. Write short notes about SQL Server. SQL Server. SQL Server is a relational database management system, RDBMS, developed by Microsoft. It is used to store, manage, and retrieve data in an organized way. SQL Server is widely used in business applications, websites, and enterprise systems because it is secure, reliable, and easy to manage. It uses TSQL, TransactSQL, an extension of SQL, to perform operations like creating tables, inserting data, updating records, and retrieving information. It also provides features like backup and recovery, data security, performance optimization, and support for large databases. Example: in an e-commerce website, SQL Server stores customer details, orders, product inventory, and payment history. When a customer places an order, SQL Server quickly updates the inventory and saves the transaction. Key features: supports SQL and TSQL commands. Reliable and secure. Handles large databases. Provides backup and recovery. Easy to remember. SQL Server is equal to Microsoft Database plus Secure plus Fast plus Enterprise use. It is suitable for businesses of all sizes needing efficient and safe data management. Next Unit 2. Long questions. First important long question is: 1. What are the characteristics of relational database design? Explain with examples. Characteristics of relational database design. A relational database design is a method of organizing data in tables, relations, so that it is efficient, accurate, and easy to manage. Good design ensures data integrity, avoids redundancy, and makes retrieval simple. There are several key characteristics that define a well-designed relational database. 1. Tables, relations. Data is stored in tables, where each table represents a specific entity like student, employee, or product. Example: a student table with columns roll no, name, class, marks. 2. Rows, tuples. Each row represents a single record or instance of an entity. Example: a row in the student table might be 101, Ravi, BCA, 85. 3. Columns, attributes. Columns store specific types of data for each record. Example: name stores the student's name, marks stores numerical marks. 4. Primary key. Every table has a primary key that uniquely identifies each record. Example: roll no in student table ensures no two students have the same roll no. 5. Foreign key. Foreign keys create relationships between tables and maintain referential integrity. Example: course ID in student table links to the course table, showing which course a student is enrolled in. 6. Data integrity. Relational databases enforce rules to maintain accuracy and consistency. Example: age cannot be negative or roll no cannot be repeated. 7. Normalization. Data is organized to reduce redundancy and dependency, making the database efficient. Example: instead of storing a teacher's department in every student record, it is stored once in a department table. 8. SQL support. Relational databases use SQL, structured query language, for querying, inserting, updating, and deleting data. Example of relational database. A college database can have tables like students, courses, departments. Student table has roll no, PK, name, course ID, FK. Courses table has course ID, PK, course name. This ensures organized, accurate, and easy to access data. Easy to remember. Tables plus rows plus columns plus keys plus integrity is equal to relational database. A good relational database reduces errors, avoids duplicate data, and makes retrieval and management fast and reliable. Next important long question is 2. Relational algebra. Relational algebra is a set of operations used to retrieve and manipulate data stored in relational databases. It provides a mathematical way to work with tables, relations, and forms the foundation of SQL queries. The main idea of relational algebra is that you take one or more tables as input, perform operations, and produce a new table as output. This helps in filtering, combining, and transforming data efficiently. Key operations in relational algebra. 1. Selection, sigma. Selects rows from a table based on a condition. Example, sigma, marks 70, student, gives all students with marks greater than 70. 2. Projection, tie. Selects specific columns from a table. Example, pi, name, class, student, gives only name and class columns. 3. Union. Combines rows from two tables with the same structure, removing duplicates. Example, students from batch A, students from batch B, all students from both batches. 4. Set difference. Finds rows present in one table but not in another. Example, students who attended seminar 1, students who attended seminar 2, students only in seminar 1. 5. Cartesian product times. Combines all rows of one table with all rows of another table. Example, student times course, every student paired with every course. 6. Join. Combines rows from two tables based on a related column. Example, student course on course ID shows each student with the course details they are enrolled in. Example of relational algebra. A college database has student and course tables. To get all student names along with their course names. 1. Use join on course ID. 2. Then use projection to select only name and course name. Result a table showing which student is enrolled in which course. Why it is important. Forms the theoretical foundation of SQL. Helps in query optimization. Provides a clear, step-by-step way to retrieve data. Easy to remember. Selection is equal to rows, projection is equal to columns, join is equal to combine tables. Relational algebra helps DBMS to process complex queries accurately and efficiently. Next important long question is 3. Tuple and domain relational calculus. Relational calculus is a non-procedural query language used in database management systems, DBMS. Unlike relational algebra, which tells how to retrieve data, relational calculus focuses on what data to retrieve without specifying the steps. It provides a declarative way of querying databases. There are two types of relational calculus: tuple relational calculus, TRC, and domain relational calculus, DRC. 1. Tuple relational calculus, TRC. In TRC, queries are written using tuples, rows. A tuple variable represents a row of a table, and the query describes the conditions that the tuple must satisfy. Example. Find the names of students with marks greater than 70. TRC query. S.name vertical bar student, S, and S.marks 70. Here, S is a tuple variable representing a row in the student table. The result includes only the names of students who scored more than 70. Key point, TRC focuses on whole rows, tuples. 2. Domain Relational Calculus, DRC. In DRC, queries are written using domains, columns or attributes instead of tuples. It specifies values of individual columns to retrieve data. Example. Find the names of students with marks greater than 70. DRC query. N vertical bar MC, student, N, M, C, and M 70. Here, N represents student name, M represents marks, and C represents class. Key point, DRC focuses on columns, attributes, rather than whole rows. Comparison. Feature TRC DRC. Focus tuples, rows. Domains, columns. Syntax tuple condition. Example S.name S.marks 70. Why important? Helps understand non-procedural query languages. Forms the foundation of SQL. Provides a clear, concise way to specify queries. Easy to remember. TRC is equal to rows, DRC is equal to columns, both is equal to what to retrieve, not how. Relational calculus is widely used in query optimization and advanced database design, making it a key concept in DBMS. Next important long question is 4. DDL and DML constructs. In database management systems, DBMS, SQL commands are divided into DDL, data definition language, and DML, data manipulation language. Both are essential for creating, managing, and using databases, but they serve different purposes. 1. Data definition language, DDL. DDL is used to define and manage the structure of the database. It deals with creating, modifying, and deleting tables, indexes, and constraints. DDL commands affect the database schema but not the actual data directly. Common DDL commands. Create to create a table or database. Alter to modify the structure of a table. Drop to delete a table or database. Truncate to remove all data from a table but keep its structure. Example. Create table student. Role no int primary key. Name varchar 50. Marks int. This creates a student table with columns roll no, name, and marks. Key point, DDL commands are structural. 2. Data manipulation language, DML. DML is used to work with the actual data stored in the tables. It allows users to insert, update, delete, and retrieve data. DML commands do not affect the database structure, only the contents. Common DML commands. Insert, add new records. Update, modify existing records. Delete, remove records. Select, retrieve data. Example. Insert into student, roll no, name, marks. Values, 101, Ravi, 85. Update student. Set marks is equal to 90. Where roll no is equal to 101. Select name, marks. From student. Where marks 70. Key point, DML commands are data focused. Difference between DDL and DML. Feature DDL DML. Purpose define database structure manipulate data in tables. Examples create, alter, drop insert, update, delete, select. Affects schema data. Transaction auto-commit can be rolled back. Easy to remember. DDL is equal to structure, DML is equal to data. By using DDL and DML together, you can create a database, define its structure, and manage its data effectively, making your DBMS fully functional. Next important long question is 5. What are the different open source and commercial DBMS? Explain. Different open source and commercial DBMS. A database management system, DBMS, is software that allows organizations to store, manage, and retrieve data efficiently. DBMS can be classified into open source DBMS and commercial DBMS based on cost, licensing, and support. 1. Open source DBMS. Open source DBMS is free to use, modify, and distribute. It is widely used by students, startups, and small businesses due to low cost and flexibility. Popular open source DBMS. MySQL, widely used for web applications, stores data in tables. PostgreSQL supports advanced data types and complex queries. SQLite, lightweight DBMS used in mobile apps and small applications. MariaDB, a MySQL alternative with additional features. Example: a startup building an online e-commerce platform can use MySQL to store product, customer, and order data without paying for licensing fees. Advantages: free and flexible. Active community support. Easy to integrate with applications. 2. Commercial DBMS. Commercial DBMS requires a license and is usually supported by a company. It is preferred by large organizations because of professional support, security, and advanced features. Popular commercial DBMS. Oracle DB, powerful and secure. Used by banks and enterprises. Microsoft SQL Server, easy integration with Microsoft products, widely used in businesses. IBM DB2, reliable for large enterprise databases, supports multiple platforms. Sybase, used for enterprise transaction processing. Example: a bank uses Oracle DB to manage customer accounts, transactions, and loan records because it handles large-scale, high-security data efficiently. Advantages: professional support and training. High security and reliability. Handles large enterprise applications. Easy to remember. Open source is equal to free and flexible. Commercial is equal to paid and powerful. By choosing the right DBMS, organizations can manage data efficiently, meet their business requirements, and ensure security and scalability. This distinction helps students understand why small projects use open source DBMS and big enterprises prefer commercial DBMS. Next important long question is 6. Oracle. Oracle is a commercial relational database management system, RDBMS, developed by Oracle Corporation. It is widely used by large organizations, banks, e-commerce platforms, and government agencies due to its high performance, reliability, and security. Oracle can handle large volumes of data and supports complex queries, transactions, and multi-user access. Key features of Oracle. 1. Relational database. Data is stored in tables, rows, and columns, making it organized and easy to manage. 2. SQL support. Oracle uses SQL, structured query language, for creating, modifying, and querying data. 3. PL/SQL. Oracle's procedural language for advanced operations like loops, conditions, and stored procedures. 4. High security. Provides user authentication, roles, and privileges to protect sensitive data. 5. Backup and recovery. Ensures data is safe in case of system failure. 6. Scalability. Can manage small to very large databases, supporting thousands of users simultaneously. 7. Multi-platform support. Works on Windows, Linux, Unix, and mainframes. Example of Oracle usage. In a bank, Oracle stores customer information, account balances, transactions, and loans. When a customer transfers money online, Oracle ensures the transaction is processed instantly, accurately, and securely, while updating all related tables. Similarly, in e-commerce, Oracle can manage orders, inventory, and payments for millions of users without delays. Advantages of Oracle: reliable and robust for mission-critical applications. Secure for sensitive financial or personal data. Handles large databases with high performance. Supports complex operations using PL/SQL. Easy to remember. Oracle is equal to large data plus secure plus fast plus reliable. Oracle is preferred in enterprise environments because it ensures accuracy, speed, and security even for huge amounts of data and users, making it one of the most trusted commercial DBMS in the world. It is ideal for banks, insurance companies, large IT companies, and government systems where data integrity and performance are critical.